math and geometry and all that good stuff. Tyler, what does the translation look like? Moving it from one place to another. Does the translation involve turning my shape at all? No. What would we call that?
Rotation.
That's a rotation. Does the translation involve me flipping my shape at all? No. Like we saw this week, that's called a what? Reflection. If I'm translating shape, am I making it bigger or smaller? No. What do we call that?
Dilation.
That's a dilation, right? So translation means we're literally just taking a shape and we're moving it left, right, up, down. Okay? Diagonal. We've seen translations one way. We're going to see them kind of a little bit different today with what's called a vector. Everybody say vector.
Vector.
Have you guys heard the term vector before?
Yes.
In Despicable Me?
Oh, yeah.
Is that a character in Despicable Me? Okay. Tyler, where have you heard vector before? In coding? Nice. Yeah, definitely. So a vector is basically like an arrow that has a certain direction and a certain magnitude. Magnitude just meaning length. So we're not going to get too deep into it. It's really, really simple. In general, translations slide a figure across the coordinate plane. Like I said, left, right, up, down, or any combination of those. And the rule for a specific translation we could represent as a vector, A, comma, B. What do you notice about those parentheses? They're pointy. Okay, that's how you know we're dealing with a vector, when we see parentheses that are pointy. Now on the homework, they're regular parentheses. I don't know why, but typically what you're going to see is a little vector with the pointy parentheses like that, okay? So A represents the number of spaces moved in the X direction, obviously, because it's going first. If I have a positive A value, I'm going to be translating to the right. And a negative A value, what direction do you think I'm going to be translating? To the left. Lucky guess. B represents the number of spaces moved in the Y direction. If I have a positive B value, what direction do you think I'm translating? Up. What about a negative B value? Down. So how you may have seen this last year is if I have a translation rule, it would look something like this: x plus 2, y minus 3. Does that look familiar at all?
Yes.
Yeah? Now all we're doing is taking out the x and we're taking out the y. That's what a vector is. It's the exact same thing as that rule, without the x, without the y. Does that make sense? Because it's implied if I'm in the first spot of a coordinate pair, well, that's the x. If I'm in the second spot, that's the y, right? So it's the same thing. So we're going to translate triangle DEF using the vector negative 4, 3. Negative 4 in the front tells me I'm translating what direction? Left. It's negative, and it's in the front, so it's an X movement. X is left and right. Translating left 4. Positive 3 on the end of my vector tells me I'm going which direction? Up 3. So just like I said the other day, if I'm moving houses, I got to take my bed frame apart, move it over there, put it all back together, right? So let's take this triangle piece by piece, starting with point D. Point D, I'm going to move left 1, 2, 3, 4 spaces, and I'm going to move up 1, 2, 3 spaces. There's point D prime. Then I'm going to go over to point E. I'm going to go 4 spaces to the left. 1, 2, 3, 4. 3 spaces up. 1, 2, 3. There's point E prime. Everybody with me so far? Yeah? Then I go down to point F. I'm going to go 4 spaces to the left again. 1, 2, 3, 4. 3 spaces up. 1, 2, 3. Boom. There's F prime. I'm going to put my bed frame back together now that it's all at the new house. And there's my translated triangle. So because we're using a coordinate plane and there's x direction and there's y direction, we split it up into two movements. 4 to the left, 3 spaces up. But really, like if we're not on a coordinate plane, we're just out somewhere in space, all we did was we took this triangle and we translated it diagonally up in that direction, right? But since it's hard for us to talk about like distance and length in the diagonal, we saw that with the distance formula, right? If I have a diagonal line, I have to do my distance formula or the Pythagorean theorem to figure out how long that diagonal line is. So in the same vein as that, if I'm translating on a coordinate plane left, right, up, down, I'm going to use those two different movements instead of that one diagonal movement. All right? Pretty easy. What do we think? Yeah? Pretty straightforward? Okay. Let's look at the second one. If I got a vector of 6, -4, what does that 6 tell me? I'm going 6 to the right. How do I know I'm going to the right and not to the left? Because it's positive. What does that -4 tell me? I'm going down 4. How do I know I'm not going up? Because it's negative. You guys got it. So I'm going to go point by point, count 6 spaces over, 4 spaces down, 6 spaces over, 4 spaces down, 6 spaces over, 4 spaces down. Connect all my dots. I also want to make sure that I'm labeling all of my dots. X prime, Y prime, Z prime. And there's my image triangle. Now, real quick, let's take the coordinates of x. What are the coordinates of point x in my pre-image? -3, comma, 4. What are my coordinates for x prime? Right here. 3, 0. So if I'm comparing my pre-image coordinates to my image coordinates, right? My x coordinate went from -3 to +3. What is that a change of from -3 to +3? 6 in the addition sense or the subtraction sense? Addition. So I'm adding 6 to my x. And then my y coordinates, how would I get from 4 to 0? I'm subtracting 4. Does that match up with the vector that we originally started with? Yeah. So if I'm just given a coordinate like -3, 4, I'm not given a graph, but I'm given a vector and asked to find the image, I just add 6 to the x, subtract 4 from the y. Does that make sense? Yeah. Over here, I just subtract 4 from the x, I just add 3 to the y. If I'm looking at point D, D is at 1, 2. D prime is at -3, 5. Well, how would I get from 1 to -3? By minusing 4. That matches up with my vector. And how would I get from 2 to 5? By adding 3. Does that match up with my vector as well? Yes, it does. Right? Any questions I can answer about that? Quick show of thumbs, how we feeling about that? Thumbs up sounds real good. Thumbs sideways sounds kind of good. Thumbs down sounds not very good. Okay.